Good morning to all of you. Continuing with the yesterday's part, we have seen some reaction regarding glucose metabolism yesterday. That was glycolysis. First two reactions we have already completed in the total 10 reactions or 10 enzymes that have been catalyzing these reactions. So first two steps we have already concluded, and let us continue with the same part of catabolism of glucose. So reaction 3, now this reaction 3 is the second priming reaction, and this is rather a big deal actually, because phosphofructokinase plus ATP plus fructose 6-phosphate gives fructose 1,6 bisphosphate and ADP. Now if you see the structure of fructose over here, fructose 6-phosphate. Now this fructose 6-phosphate is ultimately is gaining an ATP, or an ATP has been utilized here, and this the fifth carbon here, sixth carbon here, the water molecule absorbs that ATP. Like one reaction, these are highly irreversible steps and a major set of regulation. So this is said to be a major set of regulation, the conversion of fructose 6-phosphate to fructose 1,6 bisphosphate. Reaction 4 and 5 will double your pleasure, double your fun, get more molecules. Aldolase catalyzes fructose 1,6 bisphosphate to dihydroxyacetone phosphate plus glycerol 3 phosphate to pretty similar 3 carbon molecules. Now, this is an enzyme aldolase which converts fructose 1,6 bisphosphate into two molecules. One is dihydroxyacetone phosphate and glycerol 3 phosphate. If you see the structural way, one phosphate molecule is donated here, another is donated here. They are made up of the same reaction in 5, where a triose phosphate isomerase converts DAPH to glycerol 3 phosphate. In reaction 5, glycerol 3 phosphate is oxidized and second PI is added. See here. One PI was there and another PI has been added there. So now the product becomes 1,3-bisphosphoglycerate. Correct? This reaction catalyzed by glycerol 3 phosphate dehydrogenase. Dehydrogenase kind of enzyme is being utilized here. Remember, there are now 3 carbon molecules for every one molecule of 6 carbon materials. Okay, 3 carbon molecules. 1,3-bisphosphoglycerate is a truly high energy molecule. Correct? Reaction 6, the first dividend of the ATP paid out, catalyzed by phosphoglycerate kinase. From here, if you see the 1,3-bisphosphoglycerate, one ADP molecule is being utilized, and from one ADP, one ATP is being utilized. You can see here from this, the carbon molecule at the first position becomes unstable, and ultimately 3-phosphoglycerate is being generated. Reaction 7 to 8, rearrangement of phosphates and carbons. 3 phosphoglycerates, the phosphoglycerate mutase, again the carbon molecule from the third position is coming to the first position now. 2 phosphoglycerate, enzyme enolase catalyzes it, ultimately phosphoenol pyruvate is being generated now, which is been funneled inside the process of TCA cycle or glycolysis. See here, this is substrate level formation, substrate enzyme. You can see the enzyme, we already finished this part, and the product pyruvate with the help of adenosine is being generated, ATP molecules are formed. Now this is an important part, that ATP generation, how ATP generation takes place. That during stage 1 and stage 2 of glycolysis, 2 ATP molecules are consumed and 4 ATP molecules are synthesized. Yesterday we have seen this pathway as well. Thus the net energy yield in glycolysis is 2 molecules of ATP per molecule of glucose fermented. However, maximal ATP yield from oxidation of glucose is 36 to 38 ATP. Okay, 36 to 38 ATPs are being generated. The maximum yield of ATP glucose molecules depends on coupling of glycolysis with citric acid cycle by means of pyruvate dehydrogenase. You see here, from pyruvate, so from glucose to pyruvate through glycolysis, 4 ATP molecules are being generated. 2 NADPH ATPs, and ultimately from pyruvate to ultimately when it runs, that carbon molecule, when it's converted and runs throughout the Krebs cycle, then and only then the 36 ATP, net ATP is 36, and ultimately this process gets converted. Like for example, maximum yield of oxidation of glucose, total oxidation of glucose will lead to 36 to 38 ATPs. Correct? So this is all in terms of the process of glycolysis, which is one of the important process that is associated, or it is also called as the EMP path. Thank you.